In the year 2013, so a long time ago already, we machined this nice relief model of the Silicon Valley, Bay Area, San Francisco. As you can see here, the grain in the wood is quite prominent, making it difficult to see the small details in the model, which is a pity. That's why I wanted to try again, now using the current DeskProto version, obviously, and we got this nice panel of American poplar wood, and I'm excited to see how it will look in this wood, the same model. Well, the digital elevation data for this model has been obtained from a website as a free download from the website of the US Department of Agriculture. You see it here. On our website you can find instructions exactly step by step what we did to create this data set for Silicon Valley. The Silicon Valley dataset that we're going to use is a free download on the DeskProto website, so you can make your own model if you like. Okay, first step, what I want to show you is how to download this bitmap file for this project. The first thing to do is download the image file containing the bitmap of the Silicon Valley, the height map. It can be found on the DeskProto website, deskproto.com. In the download menu you can find the free models. DeskProto offers a number of free CAD files for CNC machining, 2D files, DXF files, 3D files, nice STL files, and the third category is image files. And here is the height map of the Bay Area. So the blue is in fact black. It has been colored blue in this image to give a better view. Okay, here is the download link. Right mouse click and save link as, and I will save it on my desktop. Here we go, and all set, and I can continue with DeskProto. So that was downloading the PNG file for Silicon Valley. Next step obviously is to start DeskProto, load that CAD data, that PNG file as bitmap file, and create the toolpath. I will show you how that can be done. As you can see, I prepared an almost empty desktop. Here's DeskProto. This is the relief file, the bitmap file, sorry, that I just downloaded. And here we have a DXF file with the text we engraved. I will come back on that later. First, start DeskProto. It's the Expert edition. For this project you will need Expert or Multi-Axis edition. We want to start a bitmap project. And the bitmap file was on the desktop. Here we are, Bay Area height map, and it reads it and it will display it on the screen. Here we are, a top view. Well, to give you some orientation to show what's happening, I will quickly rotate 90 degrees to have the north on top. So what you see here is the Silicon Valley. This blackest part is the bay. Here's the sea, San Francisco, the Golden Gate with the Golden Gate Bridge. Well, that's the relief we want to machine, and it has been orientated with the longest axis along X, as on the milling machine I want to use the X-axis is the longest. Okay, we want to start with entering parameters on 3 levels, project, part, and operation. First, the project parameters. These are quite simple, not much needs to be done here. You only need to check if the machine is the correct machine. Well, here it is, so I'll just press cancel and continue. The part parameters define what we want to machine, and the operation parameters define how we want to machine it. First, the part. As you can see, it shows a red warning because the original CAD data is far too large for the small machine that we're going to use. So first thing we need to do is the size. which is on this tab. Working area for my machine is 400 by 300 millimeters, so the Y size is the limiting factor. I'll put the size on dimension on custom and put that to 300 millimeters. So this is the size of the relief that we want to machine, and you can see if I press apply, the red warning has gone. So this is a part that we can machine. More settings for what we want to machine, obviously the Z. So the Z setting defines how DeskProto will convert the gray values in the bitmap to Z heights in the relief. Top of the block is 0, white is highest, so I will put white on 0, and the total block is 20 millimeter thick. So my for black here, the C, the black is the lowest part. I'll put it on -10 to have a total relief depth of 10 millimeters. Next is the material. My block of poplar wood is 400 by 326 millimeters, so I can have a small border of 13 millimeters on all sides. So I make that 313 minus 13 here again minus 13, and on the right side I'll add a bit more to come to my 400 millimeters. Here we are. This is the block, and here I have some room to engrave the text below the relief. The block also, as said, is 20 millimeters thick. So this is the block we want to machine. One more thing to do, the 0 point, by default DeskProto puts it on the corner of the block. That's not what I want, because now this will have an I coordinate of 330 millimeters, which is too much for my machine. So I want to change the 0 point, and for X and Y I'll put it to none. So now the 0 point is exactly on the corner of the relief that I'm gonna machine. Okay, those are the part parameters. Here is the block, 0 point, relief, room for the text. Continue with the operations. For this project I want to use 3 different operations, roughing, semi-finish and finish. So let me start by entering the parameters for the roughing operation. I also call it roughing. 6mm bullnose cutter, that's okay. The roughing settings will be that I want to use a skin of 0.5 millimeter, and I want to go down in 2 layers of 5 millimeters each. You remember total relief depth was 10 millimeters. The step over may be a bit larger, the distance between toolpath and the step size along toolpath. I want to change those values. It may be a bit faster, and certainly the cutter may move faster. Well, these are settings for my machine. On your machine they may be different. Strategy parallel to X is okay. Roughing, I just set those. The area is important. I do not want to machine the complete block. I only want to machine the bitmap area. And then for borders, I also want the cutter to stay exactly within that area. So the outer wall will be the same for all cutters, for all 3 operations. So those are the roughing parameters, and I can now calculate the toolpath. Let me rotate this a bit and switch the bitmap off. Here we are. So you can see 2 layers of toolpath are present, and well, not much to be seen right now. So I'll just continue with the second operation, which will be the semi-finish. I'll copy this one. I'll call it semi-finish. Yes, a thinner cutter, 3mm bull nose. No roughing options for this one. No layers. The toolpath distance and step size feed rate, spindle speed are okay. Strategy the same is okay. Area and borders, well, I copied those so they can remain the same, so I can continue calculating toolpath immediately. Make roughing invisible by clicking on this lamp icon, and here you can see a bit more detail, but still it's quite vague. The finishing will be needed to reveal all details. So again, copy operation, call it finishing. Yes, a 1mm bullnose cutter, very small precision values, 10 toolpath per millimeter. And for this very thin cutter, I'll want to select a higher spindle speed. Strategy not parallel to X. This one I want the toolpath parallel to Y. Y, yes. No roughing. Again, area and borders can remain the same. I get a warning. This small 1mm cutter is a multiple diameter cutter. The flute is 1mm and the shaft is 3mm. So DeskProto warns, make sure that the shaft doesn't collide with the material. But since we have applied roughing, that's no problem. And I can calculate toolpath, which will of course take a bit longer for this very thin cutter. Here we are, very red, so I can zoom in a bit more. Yeah, here we see Alcatraz Island, San Francisco, Golden Gate Bridge, but in order to really see some detail what the result will look like, we can best calculate a simulation. And we found out in order to get sufficient detail, we need to change the simulation settings and select the highest precision. That way it will cost some time, but well, we'll need that. First of all, it needs to display the simulation, which takes time. This is a very simple onboard graphics card. It's not so quick, so I can say, when I calculate toolpath, calculate the simulation only for roughing now. That will also take time, but I can speed up the video. This is the roughing toolpath parallel to X. Next one is the semi-finish to see some more detail. Yes, and then third, the finishing operation will of course take most time, as that is very detailed. Here we are. This is simulation of the result, and it promises to that we will have a very nice detailed model. So I can again hide the simulation, make it a bit larger, and then we can, as a final step, we can write the NC program. It again gives me warning. Bullnose cutters can go a bit deeper than the bottom of the model, but for this relief that doesn't apply, so I can put OK, and I can give the name for the NC file to be written, and you will see that 3 files are written: the roughing, the semi-finish, and now the longest one is the finishing operation. As my small machine doesn't have an automatic tool changer, DeskProto decides to save 3 different NC files, and with those files we can of course go to the milling machine. Welcome to our small workshop. For this project I'll be using our old ISIL CPM 4030 machine. The slab of wood. I've carefully aligned the wood on the working table so that my 300mm working area is in the center of the wood. I've set the workpiece 0 point, I've loaded the correct cutter, so now I can proceed to the laptop and start machining. back to the computer for the final step. Calculating toolpath for the text to be engraved here. As said, that was in a DXF file, a vector file, so when I load vector data I find it here on the desktop and it will be displayed right here. It's difficult to see, so I'll switch off the bitmap. Here we are, and it's clear it first needs to be rotated in order to have it displayed correctly. That can be done in the part parameters. As you can see, an extra set of settings has been added because we loaded vector data, and we can go to transform and rotate 90 degree. It will warn that the other items won't be rotated, but that's okay. So the orientation now is correct. We need to pan it over the part to have it on the correct position. And I know that a panning of 355 millimeters, see here, would have a correct result. Switch on the bitmap again to really see that. So that's a correct orientation for this text. So in order to machine it, I need to add a vector operation. Here we are. I call it text and a thin cutter. 1 millimeter flat tip is okay. The feed rate and especially the spindle speed again can be a bit higher for this very thin cutter. Z settings, 1 millimeter is a bit too deep. I'll make it 0.7, and I want to select all curves, all closed curves for pocketing. All. Here we are. I'll zoom in a bit, and when I now calculate the toolpath for only this operation, you can see that the text will be nicely engraved. I will again save those toolpaths. Bay Area text, yes, and this file now can be with this file, and I can proceed on the milling machine. All operations have been machined, and the resulting model looks much better than the previous model in oak wood that had so much grain. I'll zoom in a bit for some more detail. Well, as you have seen, DeskProto makes it very easy to create this model on your own milling machine. When you have a larger machine, obviously you can machine a much larger model as well. It gives an overview of the area in a way that even from an airplane is not possible, simply because the airplane cannot fly high enough. So it's an absolutely wonderful model for anybody living in this area of the world.